Yes, you're welcome to this class that we are going to have today. So as I had informed you earlier, you the premium scholars, today we are going to look at bonding. Okay, we are going to look at bonding, but then this might go to some of the newcomers that have just joined this program. You might ask, who is speaking, where is he coming from? So to solve that, my name is Mr. Henry, and what do? I teach, and I'm also a tutor of chemistry and biology. What has sent me here? Allow me in 1 minute to explain this. So what has sent me here is simply the Past Chemistry and Biology Academy. For those that don't know it, it's called the Past Chemistry and Biology Academy. What is it enrolling to? It is helping out candidates to resolve the issues they have in chemistry and biology. So after the lesson, those that will want to join the group, the Past Chemistry group, premium group, you'll have to contact me or to WhatsApp me onto this number. So I've shared also my number that you can use to see me out. So I think I've tried to explain that. So today I said we are speaking of bonding, but however, bonding comes from a topic that we call structure and bonding. Okay, so structure and bonding, it is the topic where we get the subtopic bonding. But however, in bonding today, we are specifically going to look at ionic bonding. Okay, we are going to look at ionic bonding. So I know many of you have heard this word. Some of you know it very well, but some of you haven't yet triggered. What does ionic mean? What does ionic mean? So that is what we are going to look at today. Okay, so the first thing we have to know, what is bonding by definition. Okay, so here I wrote and I told you bonding, this is a chemical combination. It's a chemical combination of atoms of an element to form a compound. What do I mean here? I mean that during this bonding that we have here, atoms combine. Atoms are going to be combined together. So these small circles are making therefore atoms. Okay, so they are going to combine together to form what we call a compound. Okay, so this is a combination of the atom. So you can call this a bond. This is a bond that is keeping these atoms to be together. Okay, so you have said bonding, this is a chemical combination of atoms of an element to form a compound. So what takes part during a chemical reaction, of which this chemical reaction here we are calling it bonding? It is the atom that takes part. Okay, so an atom is the one that takes part during a chemical reaction. Not an element, but the atom of the element is the one that takes part during a chemical reaction. So the first question comes, what is an atom, before even we start to explain where we are going. Okay, so an atom, this first and foremost is the smallest electrically neutral particle that takes part in a chemical reaction. It is the smallest electrically neutral particle that takes part in a chemical reaction. So I'm going to explain this. Let me first explain it down here. They have told us it is the smallest. By that first term, it is the smallest. By the first term, it is the smallest. It means it is the basic foundation of an element. If this is our element and it is big like this, let me say we are calling it sodium. Hope all we know the symbol of sodium, chemical symbol is Na. If this is the element as big as it is, then what makes it up? It is the atom, the foundation, the atom that makes it up. For it is small. So many of these small atoms, when they combine up, they continue combining up, they are going to form this compound. I mean this they are going to form this this element, the one that is referred to as sodium. So that is the first step. An atom is the smallest electrically neutral particle of an element. So with the electrical neutral particle, this is what I mean. I know our teachers, they drew for us this. All of us know this, but draw proper circles. Then here they put N. And they told us from that first nucleus, we draw our first energy level. Okay? But this first energy level has a maximum of what? Has a maximum of 2 electrons. Then the next that we shall have, for it begins with a maximum of what? For it has a maximum of 8 electrons. Now someone might ask me, what are those 8 electrons you're speaking about? The 8 electrons, this is the first way we display them. You first distribute them very well like that. So those are the first 4. Then now you position them by adding more 4 to make them very well 8. You add here 1, also here 1. Those are how many? 6, 7 and 8. So someone might have a question, why are they 8? You see, for an atom or for an element to be stable, its atom in the outermost shell should have a maximum of 8 electrons. So the 8 electrons, they simplify or they signify a stable electronic configuration. So if it has 8 electrons in the outermost shell, it cannot react, it is stable. Okay, but whenever it has electrons that don't reach 8 in the outermost shell, it is unstable. So what does it do? It bonds with other atoms so that it can form this stable electronic configuration. But where are we first of all? We are describing the definition of an atom. First we have said it is the smallest. Now electrically neutral particle. Electrical neutral particle, for it, where does it come from? So for that part of electrically neutral particle, let's take this electrically neutral particle. We are going to take this. So are you seeing this that I'm naming here? This one is called a nucleus. It is called a nucleus. Okay, so the nucleus, that's where we are going to find the protons, the ones that I have named by P. So these ones are protons. And then we have the N. The N is what we refer to as the neutrons. Okay, so these ones are made they are found in the nucleus of the atom. So when you take a closer look to these protons and neutrons, the number of protons which is in the nucleus of this atom is equal to the number of neutrons. What do I mean? If the number of protons is 2, the number of neutrons is also equal to 2. Okay, and by that, since the number of protons are equal to the number of neutrons, they are neutral. Since these 2 cancels out with this one and remain with a resultant of 0, implying that it is neutral. It has no charge, it is in the middle. It is what? It is neutral. Okay, so I think that one is first solved. It is, we started by saying an atom is the smallest electrically neutral particle of an element. So this atom that I have drawn, it is for an element, a specific element. You give it a name. It is of an element, of which this element can be what? Can be sodium, can be magnesium, and so many others. Okay, that takes part in a chemical reaction. That I explained it very well. During a chemical reaction, it is this atom that is going to be involved. Okay, hope that is okay. So I can proceed up where we were. So that is by the definition here. It is the smallest. You have known how is it the smallest. It is the basic foundation of an element. Electrically neutral. Why? It has equal number of protons and neutrons, which cancel out, having a resultant of 0. That takes part in a chemical reaction. Understood. So this bonding we are speaking about, it occurs in atoms of elements. But bonding is subdivided into three categories. We have ionic bonding, we have covalent bonding and dative bonding, but we are going to start with this one. So this is going to be our first one, ionic bonding in this lesson. Okay, then after this lesson we shall look at the rest. So what is ionic bonding? I hear a word ionic bonding. What is ionic bonding? So first and foremost, ionic bonding, this is a type of bonding that involves the transfer of electrons. That is where I'm taking, those are the key terms. The transfer of electrons from a metal atom to a non-metal atom. Okay, this one, it involves transfer of electrons from a metal atom to a non-metal atom. Why? To obtain a stable electronic configuration. So we are going to see this. Very well. So I said example. The example we gave here, we said sodium chloride. So sodium chloride is an example of an ionic compound. Why is it an example of an ionic compound? Let's read and see where it comes from. They are saying when sodium burns in chlorine, okay, when sodium burns in chlorine, we form sodium chloride. But what really happens for us to form this sodium chloride? So this is the chemistry behind. A sodium atom loses its electron from the outermost shell to form a positively charged ion. Let me first start from there. Let me first solve that. I think let me write it down here. So the first step, they have told us a sodium atom loses its electron from the outermost shell. Okay, so what happens? You know that sodium is given by Na. Okay, now what is the atomic number of sodium? The atomic number of sodium, it is what? It is 11. Atomic number, it is 11. But our teacher told us when you are writing electronic configuration, we start from 2. The first one has a maximum of 2, the next one has a maximum of 8. Okay, but now since this sodium, it is 11, we shall add a 1 to make it 11. Okay, so that is the first step. They are telling us this sodium loses its one electron in the outermost shell. Let's go and read and we see the other thing they are telling us. While the chlorine atom gains an electron, it gains an electron to form what? A negatively charged chlorine or chloride ion. Okay, this implies that whenever atoms of elements receive or gain electrons, they become what? They become negatively charged. So chlorine becomes negatively charged, whereas when metals lose their electrons, for them they become positively charged. So this one becomes like this. Okay, so now we are going to go and look at chlorine. Okay, we are going to go and look at chlorine. When we look at chlorine, we are going to see that this chlorine we are speaking about, we also follow its atomic number. Okay, we follow the atomic number of chlorine. Hope everyone knows that. Of which the atomic number of chlorine, it is 17. Okay, when we are writing this 17, we shall set 2. We first display the first orbital has a maximum of 2. We go to the next. The next has a maximum of 8. How many are those? Those are 10. But we have said it has an atomic number of 17, meaning the next will have a maximum of 7. Okay, so these are the 17, and you can see that it is not stable. Since we said for it to be stable, the outermost shell should have what? Should have 8. Also, this one is not stable because the outermost shell has 1. So what happens? This is what happens, and you have to show this in your work for explanation. So I'm going to draw for you the orbital here of sodium. Please, you comply with what I'm writing. Since it is not easy, try it using the system, but we shall be solving that. So we are going to start with sodium. This is the first orbital, okay, and it has a maximum of 2, 1 and 2. Okay, from that we are going to go to the next one. It has what? It has 8. Those that are asking what I'm copying, I'm getting it from here, from the electronic configuration we arranged it. This is going to be 1, 2, 3. This will be 4, 5, 6, 7 and 8. Okay, then we go to the other one, the last one. The last one here, it has a maximum of 1 electron. So you put its electron here. So that is for the case of what? For the case of this sodium. But then our chlorine, which is here, for it has this. Our chlorine, which is here, this is its whatever. For it, its first energy level, it has also a maximum of 2. Okay, then its next energy level, it has a maximum of 8. You can see that 1, 2, 3, 4, 5. So that's how you first have to distribute them: 6, 7 and 8. Whereas its outermost, for it has 7. Okay, so please, you draw proper circles for your teacher. This is just a rough work. This is 1. Don't draw rigid circles like me. That's 1, 2, 3, 4, 5, 6 and 7. Now, to differentiate them so that you're not confused, to show them, let me change color. Okay, let me change color. So what happens? Are you seeing this one electron? It is going to be lost from sodium and is going to come here where we are having our chlorine. Then it will add itself here. When it is going to be displaced from sodium here, meaning sodium has lost, sodium is going to remain with the 2 to 8. Sodium is going to remain to 2 to 8. Then this one is going to get a new stable configuration, which is 2. These first 2 electrons inside, hope you're seeing them, to 8. Then at the outermost part, it had 7, but we have added there 1. So it is 2 to 8 plus 1 to 7, which is 8. Okay, so here it is also 8. So you can see that now, right now, they are stable. This is stable, also this one is stable. Why? Their outermost electron, or their outermost energy level, it has the 8 maximum electrons, this and this. Okay, so here we have had sharing, losing of electrons, not even sharing, losing of electrons from sodium. When sodium lost, it became Na. It became Na and a positive charge up. This positive charge symbolizes that it has lost. Okay, and it symbolizes that it has lost 1 electron. If there were 2 electrons on sodium, then we're going to say Na 2 plus 1, but that does not exist. In sodium, it only loses 1. Hope that is understood. Then this one that has gained, it has also gained 1 electron. So we say Cl, it has gained 1. When it gains, it becomes negative. Okay, so that is a negative, you see. So what is the resultant? The resultant of this, we are going to repeat, but now I'm not going to draw all. I'm only going to draw the last orbitals. So we shall see that the last orbital is going to have 8. 1, 2, 3, 4, 5, 6, 7 and 8. This is the orbit of what? Of sodium. So here it is what? It is stable. So you put it in 2 brackets and tell them that it has lost How do they know that it's lost? You put there a positive charge. Okay, now for the sake of this one, you also do the same. I've said I'm only drawing the outermost shell, but in your paper you draw starting from the first one. Okay, so you can do this. Then this is 1, 2. Okay, let me draw it for you here. Then the outermost, this is the outermost. I have skipped the other ones so that our time is saved. So also here I have 1, 2, 3, 4, 5, 6, 7. Then the one electron that has been gained, you differentiate that. The one electron that has been gained, this one, okay, which has changed its configuration. So since this one has gained, we say it has become what? Negatively. It gains a negative charge. Okay, so that is the diagram. This is stable, this is stable. What we have formed here is what we are calling calcium, sodium chloride. This is sodium chloride. Hope you have understood that. The first basis, I said you start from what is an atom. Then from what is an atom, you identify the atomic number of sodium, which is here. You identify the atomic number of this sodium, then you also identify the atomic number of chlorine. Those atomic number are going to help you to draw the electronic configuration. From the electronic configuration, you're going to draw the diagrams. And we say the first one has a maximum of 2, while the outermost maximum of 8. So this is ionic bonding. Let's go back and read. In fact, you can take a screenshot. Hope you're done. So let's go back. So this is what they were saying. When a sodium atom loses its electron in the outermost shell, it forms what? Positively charged sodium ion. And we have seen how it looks. It is Na and a plus. Na and a plus, implying that it has lost one ion, one electron. Okay, while the chlorine atom gains an electron, it gains an electron to form a negatively charged, which is this one. Okay, so the cation is the one, the cation is what we call the positively charged ion. Then the anion is what we call the negatively charged ion. Okay, so in chemistry, allow me use this. This Na is called a cation. Why? It is positively charged. So the cation of sodium and the anion of chloride are held together by a force of attraction known as ionic bond. So it is the ionic bond that keeps them together. Okay, hope that is understood. But this force of attraction that holds them together, you can, if you want to speak it out, it is the electrostatic force of attraction. Okay, so that is it for today that we're discussing. Maybe a little hit. I repeat where we said we were speaking about bonding. Okay, bonding, which is here. We said what is bonding? Chemical combination of atoms of an element form a compound. We say it is an atom that takes part in a compound, but we have 3 categories. And we said for us, we have started with ionic. Ionic, we said it occurs between metal atoms and non-metal atoms. We gave an example of sodium chloride. Now, let us see a sample question. I always want sample questions, because yes, the notes are there, but how is it being set? Let's go and look here. So we have a sample question. Here they told us, and it is always going to come from item 2. They told us a construction company relies on calcium metal to produce calcium oxide, which is a very important component in cement during its manufacture. Hope you can see that. During its manufacture, so as to make it reliable, durable, during storage and construction. So they are telling us calcium reacts with air in the above equation. So this is the equation. Okay, they are telling us calcium plus oxygen, they give us calcium oxide. Okay, but before even I go so deep, someone might ask me, where are these two coming from? I'm seeing here 2, also here 2. Let me show you. So when you have calcium, I'm not going to write the state symbols, plus oxygen, it gives us what? It gives us calcium oxide. This is what we first have in the first place. But these two, the two that you're seeing here, they come as a result of balancing the equation. So how do we balance? This is how we balance. So you first compare how many oxygens do we have. This side you have 2 oxygens, this side you have 1 oxygen. What do you do? If here we have 2 oxygens and here you have 1 oxygen, you put a 2 here to balance them. When you put a 2 here, it means that we have 2 oxygens this side, also this side you have 2 oxygens. But now we have affected the calcium. The calcium here, they have also become 2. So what do you do? Also on the side of calcium, this side, you put that 2. Okay, so that is the resultant of this equation that you see. What is the question? They told us, as a chemistry student, do what? Explain the category of the material formed. So this is how they explain. On item 2, we give the category, reason, and example. This is coming from the ionic bonding that we are from looking at. So calcium oxide is an ionic compound. Why? It is having involvement of calcium, which is a metal, and oxygen, which is a non-metal. You give that reason. So this is a category. You get that tick. Why? It involves the loss of electrons from calcium metal to oxygen non-metal. That is also a tick. That is a reason. So as to obtain a stable electronic configuration, then you give an example. For example, sodium chloride. So sodium chloride is another example of ionic compounds. So that is how they answer. That is a sample question how they answer. So thanks for attending the lesson. Keep up for the next lesson. You come back, we complete. Those that want to come into contact with me to get sample items, consultations, and always attend these lessons, our numbers were provided here. You'll use this number to check me out.